Hello student, my name is Krati Gupta. I am an assistant professor in Kite Group of Institution. So in this video, we will be discussing about the topic Introduction to Stack. Okay, in this we will be studying about what is Stack. We will take some real life examples of Stack, abstract data type of Stack, and the primitive operations on Stack. So let's start with the first topic, that is what is Stack. Stack data structure was first proposed in 1955 and was patented in 1957 by German F.L. Bauer. Stack is a linear data structure. Now, linear data structure, what is mean by linear data structure? Linear data structure is a data structure in which each element of this particular data structure is accessed linearly. Means you can access the data elements of this particular data type in a particular sequence, in a linear sequence, that is one by one. Okay, we will be studying by taking an example. It is also an ordered collection of homogeneous data element. Homogeneous means similar type of data elements, same the collection of element which are of same data type. Okay, stack is also called as LIFO data structure. LIFO means last in, first out data structure. That means the element which is inserted at last will be deleted first from the stack. Okay, elements are added and removed from the top of the stack. In stack, there is a data variable which is named as top. This top variable points the last index location of the stack. That is, element which is inserted at last is pointed by top. The address of the last element or the index location of the last element is referred by the top variable. Okay, example of stack can be a pile of books. Okay, one book is kept over another, then uh, other book is kept over the second one, now the fourth one is kept over the third one, now the fifth is kept over the fourth one. Like this, what we are doing is we are inserting the element after the just after the last element. Okay, now if you want to pick up a book, now which book you will be picking? The book which you have kept at last is will be the first one which you will be picking up. Okay, so some real life example of stack is a stack of cafeteria trays, stack of pennies, stack of shoebox, stack of neatly folded shirt, pile of books. Okay, etc. Now if you want to pick any if you want to insert one more data element, that is, if you want to keep one more neatly folded shirt, where you will be keeping? You will be keeping at the top position. Okay, and if you want to pick any shirt, which one you will be picking? The one which you kept at the last. So stack is a similar data structure in which elements are inserted from the last index location, and the element which you have inserted at last is the first one to be deleted from this particular data structure. Okay, next we will be talking about the abstract data type. The abstract data type, what type of data structure is stack? Stack is the data structure in which we want to insert elements, in which we want to store our data elements in such a way that elements are stored inserted in a last element is inserted at the last of the stack. Okay, and the element is deleted from the this particular last index location. So this last index location is referred by a variable, last index location stored in a variable called top. And now the two types of operations which we are performing in our data structures are primitive operation which we perform on stack data structure is push operation and pop operation. Basically what operation we perform? We insert certain data elements in a data structure, or we delete certain data elements from the data structure to perform any other operation. So push operation is a insertion operation and pop operation is a deletion operation. If you want to insert an element into this stack data structure, then this operation is called as a push operation in stack. And if you want to delete an element from the stack data structure, then that delete operation is called as a pop operation. Okay, now if we want to do insertion in a stack, then operation is called as a push operation, and inserting an element on the top of the stack is done only if the space is available in the stack. That is, if you want to insert any element, let's suppose we are talking about that we have a pile of disk. Okay, you have a pile to place the you have a CD box. Now you have to keep the CDs in this particular box. Okay, so if you are putting a CD in a box, putting a CD means you're keeping a CD in a particular that CD box. That is called as what? Insertion operation. And now when can we put the particular CD in that box? If the space is available for that CD in the box, then only you can put that CD in the box. So insertion operation can only take place, we can only insert an element in the stack if the space is available in the stack. Okay, next is a deletion operation, that is called as pop operation. Now we can delete an element from the stack. The place from which we are deleting an element is the last index location, that is referred by the top variable. So deleting an element from the top of the stack, we are deleting an element from top of the stack, and we can only delete that particular element from the stack if stack is having more than one element. Okay, deletion is possible, you can delete an element only if there is a more than one element in the stack. You can take a glass of water from the jug only if jug contain any water. If jug is empty, then you cannot take one glass of water from the that particular jug. You cannot delete an element from the stack if a stack is empty. Okay, so push operation can be done only if the space is available in the stack, and pop operation can be done only if certain element is present in the stack. Okay, so this is the abstract data type. The primitive operation on stack, there are two primitive operation. First is the insertion one, that is called as push operation. Other is the deletion one, which is called as the pop operation. Push operation is the process of adding a new element to top of the stack, is called as a push operation. Suppose we have a stack and that stack contain one as a data element. Okay, now we have to insert a data element, that is 2 in this stack. So this element is 2 is pushed into the stack. So 2 is stored at the top of the stack, that is above the 1. Now we have to insert 3 in the stack. Again we have pushed 3 in the stack. 3 is stored at the top of the stack. Now we have to insert 4 in the stack. So we have pushed 4. 4 is stored at the top of the stack. Now we have to insert 5 in the stack. We have pushed 5. 5 is stored at the top of the stack. Now we are pushing 6, and suppose the size of the stack is 5, then this 6 will not be stored in the stack. If the stack is full and we are performing any push operation, then it is called as stack overflow. If the jug is full and you're trying to put one more glass of water in the jug, then jug will overflow. Same, if the stack is full and you're trying to insert one more element in the stack, then it is called as stack overflow. So let's take one more example. We are pushing an item on the top of the stack. We're inserting an element. Suppose we are inserting 15. Currently this is our stack. We have enough of stack space available, and as 5 of elements are stored, so total count is 5, and top will be always point to the last element. So the last element is stored at the 4th index location, so the value of top is 4. Now if we are performing in push operation, that means we are inserting an element in the stack. So We will upgrade the value of top. Top is at the last index location. Now we have to insert. We have checked that space is available in the stack. Now we will increase the value of top. Top equals to 5. Now we will store the new element 15 in this particular top location. Now we will update the count. Count equals to 6. Total number of elements in the stack is 6. Okay. So this is called as the push operation. Now let's talk about the pop operation. The process of deleting an element from the top of the stack is called as the pop operation. Now when we have to delete an element from the stack, we are deleting from the top location. Suppose the element at the top was 6. So first we have deleted one element, 6 is popped out. Now we are again performing the pop operation. Now the top element is 5. 5 is popped out. Now again we have performed the pop operation. Then at top 4 is located, so 4 will be popped out. Again we have performed the pop operation. 3 is at the top of the stack, then 3 will be popped out. Again we are performing pop operation. 2 was at the last top location of the stack, 2 is popped out. So this is called as the pop operation. Let's take one more example. We are pop an element of the stack, top of the stack. We are deleting an element. Okay, so at the, if in this particular stack more than one elements are present, stack is not empty, that means we can perform the pop operation. Total number of elements which are present in the stack are 5. So the count is equals to 5, and top always point to the index location where the last element is stored. The last element is stored at the fourth index location. So the current value of top variable is 4. Now if we are performing pop operation as the number of elements are more than 1, more than 0, so last element will be deleted. Last element is stored at fourth index location, this will be deleted. Now top will point to the last index location as 23 is deleted, so the last, now new last element become 15. So top will point to this particular index location, so top value will be top equals to 3 as one element is deleted. So if we want to insert an element, that is if we are performing push operation, first we need to increment the top value and then we are storing the new element in this top index location. And if we want to delete an element, we will store the null at the current index location of top, and then we will decrement the value of top by 1. So this is the stack data structure where insertion and deletion both occurs from the single end, and that particular end is called as top. Okay, so insertion also take place from top index location and deletion also take place from the top end of the stack. Top, we can also say that stack is a data structure which has only one end, and that particular end is called as top. Okay, and stack has two operation, primitive operation are two, that are push operation and pop operation. Push operation is inserting an element in the stack. Pop operation is deleting an element from the stack. Okay, so this is the stack data structure. Thank you.